everyone. So this is Preeti Shinde. Today we will be seeing an overview, or we will be having a webinar on understanding what is spectrophotometry. Before starting this webinar, uh, what topics we will be covering in the webinar are means we will see first the explanation on photometry, what actually the absorbance and what is the principle. Then we will see the representation of how it works, and then we will see how we at Hanna have to offer in this particular range of science. What is spectrophotometry? Spectrophotometry is nothing but a method to measure how much a chemical substance absorbs light by measuring the intensity of the light as a beam of light passes through the sample solution. Okay, the basic principle is that each compound absorbs or transmits light over a certain range of wavelength. So spectroscopy is nothing but the study of absorption or transmission of light or any other radiation that and of other radiation in respect to the you can say chemical substance that absorbs that particular light of a particular wavelength. Okay, so it involves splitting of light, means it's the splitting of light into a spectrum and into its constituent wavelength, and then selection of wavelength, and then seeing the absorption or transmitting of that particular chemical substance. Okay, so this is spectrophotometry. So what is electromagnetic spectrum? As you as you can see on your screen, there is wavelength. There is different wavelengths means representing the different components of light spectrum. Okay, of light. So light consists of this different types of wavelength. Electromagnetic spectrum is range of frequencies of electromagnetic radiations and their respective wavelengths and photonic energies. So if you could see that there are radio waves, microwaves, infrared waves, visible wavelengths, ultraviolet, X-rays, gamma rays. So radio waves are especially used into radio frequencies. Then microwaves are used in microwave oven that cooks your food. Infrared light is used in remote controls. It is used into the uh, heat specific meters or heat sensitive meters. Visible range is the light that you can see, which is visible to naked eye, which is visible. Different colors that are visible to human eye is visible range of electromagnetic spectrum. Ultraviolet is widely used into industrial uses like killing variety of bacteria, so creating fluorescent effects. Then it is also used in phototherapy. Then if you get any sun tan, that is also due to ultraviolet rays. Then X-rays are used into X-rays are used into the getting of X-ray of your body. X-ray. Then gamma rays are electromagnetic. Sorry, it is a spectrum of electromagnetic waves which are radioactive, which harm your body. There are Thus, there is the visible spectrum lies between 400 to 750 nanometer. That's it. This is the only small part that is visible to human eye. Then, what is the basic principle of spectroscopy or spectrophotometry. So there Beer's law and Lambert's law. The Beer's law stated that concentration is directly proportional to the absorption, whereas Lambert's law stated that path length is directly proportional to the absorption. Combining this both the law states that Beer-Lambert's law where absorption is directly proportional to the product of concentration and path length of the of the given sample, which is equated by a molar extinction coefficient. Molar extinction coefficient is nothing but a constant which remains constant with any change in concentration. So this is when you plot a graph of absorption versus concentration, you get a straight line. So there the gradual increase of concentration and absorption is in the multiples of this molar extinction coefficient. Okay, but then whenever you see a light of a particular color is not the color which it absorbs. If you see a yellow color, then the absorbed color by yellow is blue. If you see a blue color, then the absorbed color is yellow. So each and every color have its complementary color for absorption. So color observed is not the color absorbed. If you see a if you see purple color, then the purple color absorbs green color. Hence, we are able to see purple color. So these are different uh, observed color to its complementary absorbed color. Then, what is the difference between a photometer and a spectrophotometer? The photometer consists of a particular LED source of light of particular wavelength. Then it emits that light, passes through the sample and towards detector. Hence you get the reading. So that is the reason why so many of the photometers can measure single parameters or one or two parameters only. Or if you have benchtop meter that Hanna provides, which can measure 83 to 73 parameters, though they also are developed in such a way that they will work on specific wavelengths of light only. Okay, so these are photometer. But then, what is the spectrometer different from a photometer? So, if you add a monochromator in between the source and the sample, then it becomes a spectrophotometer. Spectrophotometer gives you an aid of split of selecting the wavelength light of desired wavelength. Okay, every means as in photometer, you will not have a limitation of a particular wavelength only. You don't have to select any one wavelength out of five wavelengths, two wavelengths, three wavelengths. No. In spectrophotometer, you get a liberty of selecting any desired wavelength of light to you can say have a quantitative or qualitative analysis of your sample. So this is the reason why spectrophotometer is way more feasible to use than that of a photometer and is way more accurate than photometer. So this is the representation of a spectrophotometer. So it consists of a source of light, a focusing lens, a prism or a grating which splits the light into component spectrum, then a filter which isolates the desired wave light of the desired wavelength, then it passes through the sample and goes towards the detector. Transmitted light goes towards the detector. So we will see that representation. So light emitted goes towards the prism or the grating, then it spreads the light and then it passes through the filter, goes through the sample, the light is absorbed here and transmitted light goes towards the detector and get the reading. Okay, so we will see once again. Okay. So these are the some parts of a spectrophotometer, some important parts of a spectrophotometer. So it consists of a lamp or you can say a source. Source can be tungsten filament lamp if it's visible. It can be um, You can have two sources like deuterium and tungsten filament lamp. Deuterium which works in UV range and tungsten uses in visible range. Or you can have a xenon lamp. Xenon lamp which works on both the wavelength spectrum, UV as well as visible. So you can say xenon flash lamp. Then you have a monochromator which splits the light into its component spectrum. So instead of a prism, you can have a grating. These days, people offer a grating of 1200 grooves, 1500 grooves per millimeter. So accordingly, manufacturer selects grating which is more accurate towards the next cycle. Then you have a filter wheel which selects the desired light only, and then you have a beam splitter to uh, correct to see whether the light is correct, light that is passed through the sample is correct or not. A beam splitter splits the light into two. One goes towards the reference detector and another goes towards the cuvette. Okay, so here you verify whether the light which is passing through the sample is correct or not, and then you have a sample compartment where you have to put a sample. This sample compartment can support many types of cuvettes depending upon the make of a spectrophotometer you are using, and then a detector. Detector can be PMD detector, PMT detector, or silicon photodiode detector. Then what Hanna has to offer? Hanna offers HI801-02 Spectro-Iris spectrophotometer, which have measurement modes of absorption, transmittance, and concentration. Other than this, you can measure units of ppm, milligrams per liter, ppt, pco, pfn, many of them. You can use for concentration units. This wavelength ranges into visible spectrum only. We have photometric range from 0 to 3 absorption. Hence, you can use this spectrophotometer in your research labs as well. Then you can have a maximum of 5 wavelength measurements. Then there are 5 timers. You can set 5 maximum timers if you have to set a reaction timer for it, and then you can calibrate up to 10 maximum points for a user defined method. Then the most important feature of Iris HI801 is it have a replaceable lamp. Replaceable lamp is very much a useful feature because user himself also can replace this lamp. Yes, there is no need to have every time a HANA HANA engineer or HANA person to come and replace the lamp. User himself can replace the lamp. It is a very easy process, and every time this lamp will be aligned in similar position. Hence, there is no you can say hassle for a user to wait until a HANA personnel comes and changes the lamp. Cuvettes, this yes, the HI801 supports 5 different types of cuvettes. It supports 10 square cuvette, 13 round cuvette, 16 circular cuvette, 22 circular cuvette, and 50 rectangular cuvette. So according to your samples, you can select the cuvette for your measurements, and all the adapters are supplied with the meter itself. Then this meter have a capacitive touch keypad, thus there is no hassle of pressing buttons. You can have very easy uh, and delicate work on the meter. Also, it is splash proof to water. Then you will have 150 pre-programmed methods that are especially for water analysis. Other than this 150 pre-programmed method, you can set 100 user methods which can be calibrated up to 10 calibration points, and the calibration indicator is displayed on the screen itself. After calibration, you will get the linear regression as well. You will have the slope, you will have the offset values, and you will have the aspect values to see whether your calibration is passed or not. So if you have any questions regarding our spectrophotometer, you can mail me on application@hannainst.in. Thank you everyone. This is Preeti signing off.